Hi there, welcome back. In this video, I want to review identifying domains and ranges of rational functions. Here I have a selection of questions very similar to what you will see in the SAT math. Remember, when identifying domain or range, you can never have the square root of a negative number, or you can never divide by 0. So these are the two things that we need to keep in mind. What I'd like you to do now is pause your video and try the question you see on the board, and then we will move forward and practice as many questions as we have here. So let's get started. And read this question: the domain of which a function does not include 2? So all you need to do is see which of the following choices, when you plug 2 for the denominator, it gives you 0. So we can almost do this in our heads. So 2 squared is 4, 2 cubed is 8 times 2 is 16, 4 minus 16 is not 0. So A works. What about this one? 4 minus 1, 2 over 2 is 1. Well, numerator doesn't matter anyway, so let's just look at the denominator. That's 2 squared. 2 squared is 4, 4 times 2 is 8. And again, the denominator is not 0, so this works. What about this one? 2 cubed is 8. Put a little 8 there. 2 squared is 4. 4 times 2 is 8. 8 minus 8 is indeed 0. So the question says, the domain of which of the function does not include 2? This domain will not include 2. So the answer is C. Let's move on to the next question. I'd like you to pause the video and try this one, and then we'll go through this. Okay, so you might recall that this is a sinusoidal wave, and the amplitude is 7. I'm just going to sketch it out. And that negative sign basically means a reflection of the sine wave. Sine wave goes up and down like this. So reflection of the sine wave in the x-axis will go down, up and over. It's not asking us to draw the function, it's just asking for the range. So the range is going to be all the way from 7 to negative 7, because 7 is the amplitude. So let's go ahead and look at all the choices and see which one works. All real numbers greater than or equal to negative 7 and less than or equal to 7. Well, this one works. Let's go ahead and check the others. All real numbers greater than or equal to negative 7 but less than or equal to 0. That does not work. All real numbers greater than or equal to 0, less than, no, that doesn't work. Less than or equal to 8 doesn't work. All real numbers greater than or equal to 0 and less than or equal to 1/8. Well, that does not work. All real numbers greater than or equal to negative 1/8 and less than or equal to 0. Well, that doesn't work, because 1/8 has nothing to do with the amplitude. We can get information for the period out of there, but definitely not the amplitude. Okay, how about this one here? What is the domain of a function which is equal to square root of 4 minus x squared minus 5? Remembering that you cannot have a square root of a negative number. So what that means is that whatever's in here must be positive. So the best thing to do would be to just go ahead and say 4 minus x squared minus 5 must be greater than or equal to 0, and then we can solve for x here. First I took the 5 on the other side, square root both sides. 4 minus x gives you positive root 5 or negative root 5. So negative x is greater than root 5 minus 4 or negative root 5 minus 4. If you divide everything by negative or multiply by negative, you have to flip the sign here, and multiplying this by negative, distributing the negative over root 5 and negative 4 gives you negative root 5 plus 4. Distributing the negative over negative root 5 minus 4 gives you positive root 5 and positive 4. Okay, this is an inequality, so we have to test our regions here. So I want you to draw a line here. Let's say 4 minus root 5 is here somewhere. That's that one here. And let's say 4 plus root 5 is here somewhere, plus square root of 5. And then what you need to do is test each region and see which region gives you positive. So let's say you tested a 0 here. Let's say you picked a 0. 4 minus root 5 is still a positive number. So if you put a 0 here, 4 minus 0 is 4. 4 squared is 16. And 16 minus 5 is a positive number. So this region will give you positive. Okay, so testing in between here, let's say we picked 4 to test. 4 minus 4 is 0. 0 squared is 0. 0 minus 5 is negative. So in this region, your inequality is negative. So let's say you picked a large number, say 10. If you plugged it in here, you'll find that the answer here would be positive. So this region is positive here. Okay, so you want 4 minus x squared minus 5 to be positive. So this is your domain, and this region is your domain. So now that you know which it is, so now we can go ahead and pick the correct answer. So x is less than 4 minus root 5, or x is greater than 4 plus root 5. That looks like it's going to work. So the correct answer is C. Now pause your video and try this one. I think here at the bottom, you don't want the absolute value of x to be equal to x. Otherwise, this whole thing will become 0. So this is a condition that must never be equal to that. So let's go ahead and plug in numbers and test each one. Let's say, for example, for the first one, let's pick negative 5. Is absolute value of negative 5 is indeed not equal to negative 5. So this is a possibility. Or what about something greater than 0? How about 1? Absolute value of 1 is indeed equal to 1, so we reject B. What about something less than 0? For example, negative 1. So is absolute value of negative 1, is that equal to negative 1? And it's not. So we have two possibilities so far. How about something greater than 1? Is absolute value of 2 equal to 2? Well, we're going to reject that because we want it to be not equal. Something greater than 4, is absolute value of 5 equal to 5? And we will reject that because we want them to be not equal. So we have two choices here, A and C. Now, if we picked choice A, we're actually eliminating the numbers from, say, 0 to negative 4. So we have to pick C to make sure that all of the choices are included. I also like to look at it from a number line point of view. So this would be choice A, and this is choice C. And for choice A, if this is 0, and let's say negative 4 is here, and they're telling us that the domain is all of these values, which is true, it works. But what about if this is 0, and what about the numbers between 0 and -4? That piece right there, this piece here, is not included. It's not included in choice A. So that's the reason why we will choose choice C. Okay, moving on. Okay, again, I'd like you to pause the video and try this. So let's go ahead and look at this problem. Which of the following functions has a domain of x is less than equal to -3? Excuse me, x is less than equal to 3. So here's 3, and that would be your domain range. The best way to do this is to pick a number in the domain range and see if it works. So for the first one, I picked 2. 3 minus 2 is a positive number, and I can indeed fourth root a positive number. You can never fourth root or square root a negative number. So this is positive, and I can do that. So this works. Testing for B. So if I picked a number in the domain range, say 7, -7, and if I plugged in -7 here, I'll get a negative number. I cannot square root a negative number, so we reject B. This is a cube root. You can cube root any number, so whether it's positive or negative. So I think this is a possibility. I can pick any number in the domain range. Let's say -7 or 0 or 2, it will work. Now the problem with C is I can make it work in this region as well. I can pick a +5 and plug it in for x and make it work. So I will reject C on the grounds that it works for the non-domain range as well. So this one also works for x greater than equal to 3. Test for D. 2 minus x, it's raised to the quarter, or it's a fourth root, so I must not get a negative here. If I picked a number greater than 2, if I pick 3, 2 minus 3 is a negative number, and I cannot work with that, so I will reject D on the grounds that I can get a negative number here. E is good for all of the ranges here. It also works for greater than equal to 3. Let's say if I picked a number 7, which is not in the domain range, it will work. I can also pick 3, which is in the domain range, and it also works. So on that ground, I will reject E because it also works for values greater than equal to 3. So the final answer is actually A. Next question. Pause your video and try this one. And this time they're asking about the range of the function that is defined by 1/3 to the power x squared plus 1 for all values of x greater than equal to 0. So we know that this is an exponential decay. I'm going to pick two numbers. If I plug 0 for x, the y value would be simply 1/3 to the power 1, which is 1/3. If x is 1, 1 squared is 1, 1 plus 1 is 2, so 3 squared is 9, so the y value is 1/9. And I know the shape of the exponential decay is something like this. So this is my 1/3, and that's the graph right there. This one is a little easier. It's linear. The y-intercept is 3. It's going to be open circle because it's less than 0. And the next point, I use the slope to get my next point. It's up 5/1 or down 5, left 1. And that's my graph right here. And I only need the graph for x is less than equal to 0, and I don't need this other quadrant here. So what's the range? The range is all of the values less than 3. Answer is y is less than 3. I'll pick C. I feel like this should be y is less than 3 here. I apologize for this typo. But let's move on to the next question. But again, pause the video and try this problem. Which of the following expresses the range of values of y is equal to gx if g of x is 5 over x plus 4? Recall that the shape of the parent graph would be something like this. So let's go ahead and see where x is undefined. X would be undefined at -4. So if I were to say that this is -4, and I'll just create a y-axis somewhere here. Then, and if x is 0, 0 plus 4 is 0, so at 5 over 4, 5/4 is where it's going to cross the y-axis. And the other part of the graph will go like this. So the correct answer for this would be A, where y is not equal to 0. We're asked for the range and not the domain. So you can see that the range, you can have any range values except for 0. So the correct answer would be A. All right, another one. Pause your video and try and figure out where x is not defined. In this question again, you don't want the denominator to be 0, so 2x squared plus 10x plus 8 should not be equal to 0. Factoring the 2 out, dividing both sides by 2, and factoring the quadratic equation, we get x plus 4, x plus 1. Solving for x, x should not be equal to -4, and x should not be equal to -1. So your answer choice is A. How about this one? Pause the video and try this on your own first and then run the video. What is the domain of the function of f of x equals log of square root 2x squared minus 15? So 2x squared minus 15 has to be a positive number. Solving for x, you get x has to be greater than square root of 15 over 2, or x has to be less than negative square root of 15 over 2. Plugging 15 over 2 in your calculator, you get 2.7. So x must be greater than 2.7, or x has to be less than 2.7 for this 2x squared minus 15 to be positive. So the correct answer is C. This is the last question. And again, pause the video and try this on your own and then run the video. So this is very similar to the last one. The domain of the function, 3x cubed minus 7 has to be a positive number. 3x cubed minus 7 must be greater than or equal to 0. So solving for x, x cubed must be greater than or equal to 7/3. X must be greater than or equal to cube root of 7/3. Use your calculator to figure out what cube root of 7/3 is, or you can simply go 7/3 raised to the power 1/3 on your calculator if you don't know how to do cube root. So 7/3, tuck it in parentheses, raise it to the power 1/3, and your final answer should be 1.33, and the correct answer is C. Thank you very much for doing these 10 questions. This ends the practice session here, and I will see you again. Goodbye.